day, viewers. Welcome to the Physics Mind. Today, we will be looking at projectile. And what is a projectile? A projectile is any object that is thrown into space that moves in a curved or in a parabolic path. So any object we throw into space and that object moved in a curved path, then that object is called a what? A projectile. It can be a stone, it can be even this marker I'm holding, it can be a ball, it can be any object. So far that object moves in a curved path, that object is called a projectile. And a projectile motion is a motion of an object along that curved path or along that parabolic path. Okay, so examples of projectile motion include an athlete that is what? Performing a high jump. And we also have a stone that is released from a what? A catapult. We also have the what? The motion of a what? Of a shot put or a javelin that is thrown into what? Into air. So all these are examples of what? Projectile motion. And one thing we also need to know about the projectile motion is that a projectile, since we say it's an object, at every point of its motion is characterized by two independent what? Velocities or two independent motion. And these two independent motion, we call them the horizontal component or horizontal motion at a constant velocity, and we have the vertical motion that is due to gravity. Okay, so what we are saying here is a projectile at every point of its motion have these two independent velocities. By independent, we mean one is not affected by the other. So they are themselves independent. And these two independent motion or velocities, we call them the horizontal motion at constant velocity and the vertical motion due to what? To gravity. Okay, so for us to understand perfectly what this independent motion are all about, let's look at the what? The motion of an object that is thrown into space. Okay, so this is the projectile motion of an object that is thrown into space. Okay, so the object is projected with an initial velocity u, and let's take that this initial velocity u is inclined at an angle, let's say theta, to the horizontal, and that object keeps moving in that curved path and then reaches a maximum height and then start returning back to the what? To the ground. Okay, so what we need to know at every point in time is that this object that have been projected with this initial velocity u have two independent what? Velocities. Now remember from vectors that when a vector is projected or is thrown, it has what? Two independent what? Velocities, which are the horizontal component and the what? The vertical component of the what? The velocity. For instance, if this is our initial velocity u, and from vector resolution, we know that we can resolve this single what? Vector into what? Horizontal component, let's say ux, and vertical component uy. And our horizontal component is going to give us what? U cos theta, while our vertical component is going to give us U sine theta. So that is still much applicable to what? The projectile motion. That is still much applicable to the projectile motion. Okay, so what we are saying is the projectile have two independent velocities, and these two independent velocities are the horizontal component, which is ux, and of course we know is u cos theta, and the vertical component of the velocity, let's say uy, which we know is equal u sine theta. Okay, so the projectile keeps what? Moving upward, and then it reaches a what? A maximum height. And let's call this point the maximum height, which is on h, and then returns to the ground. So at every point in time, this projectile has these two independent what? Velocities. And let's consider that the projectile is at this point in time, and it's going to have these two independent velocity, horizontal component, which is ux, and the vertical component, which is uy. However, once the projectile reaches the what? The maximum height or the maximum point of the what? The projection, the projectile will only be having the horizontal component. Reason being that what? The vertical component at the maximum height becomes what? 0. So at every point in time when the body is projected, it has these two independent velocities, ux and uy. But immediately the projectile gets to the maximum height, then uy becomes 0. And it's only going to be characterized with what? Ux, which is the horizontal component of the what? The initial velocity. And the projectile will again start returning to the ground. Let's assume that the projectile is at this point in time. And of course, the horizontal component still remains constant, and the vertical component will start acting what? Downward. So uy will be acting downward until the projectile strikes the ground or the projection plane again. And this horizontal distance, we call it the range, which we shall be discussing about it later. Okay, so this is just the motion of a projectile that is projected into what? Into space with an initial velocity u inclined at an angle theta to the horizontal. Okay, so the next thing we are going to be looking at is we're going to look at what is the meaning of the maximum height, and we derive the equation. The meaning of our range, we derive the equation, and also the time of flight. Now, however, before we start any of these, now let's look at or let's derive an equation for the time taken for a projectile to get to the what? The maximum height. Now, I want to derive an equation that from this point of projection to this maximum height where the projectile will reach. Okay, so from our equations of motion, from the first equation of motion under gravity. Now, from the first equation of motion under gravity, we know that V is equal to U either plus or minus gt. Now, for an upward movement, we know that the body is going against gravity, so it's going to be a minus gt. But for a downward movement, the body is acting along gravity, so it's going to be a plus gt. So since the projectile is thrown into air, it's going against gravity. So that makes it what? We have U minus gt. Okay, so at this point in time, now what is going to be our v? V is the final velocity, u is the initial velocity, g acceleration due to gravity, and t is our time taken, which we want to find. But then we want to look at the time taken to get to the maximum height. So at the maximum height, we know that the final velocity is what? 0. From motion under gravity, when we throw an object up, now the body will move with an initial velocity. But at the highest point or at the maximum height where that object reaches, the final velocity of that object is what? Is 0. So similarly, we say that final velocity, which is uy at this point, is 0. So it means that at the maximum height, our final velocity is equals what? 0. So when we substitute, we are going to be having, and before the substitution, now what is going to be our initial velocity at this point in time? Now remember we said that the initial velocity has two components always, which is the horizontal component and the vertical component. So at the maximum height, now the object is going to have only the what? The vertical component of the what? The initial velocity. And why is it the vertical component? Remember we said that the two velocities are independent of each other. Now the vertical component is only affecting the what? The height, the height of the object above the what? The ground level. while the horizontal component is only affecting the horizontal distance moved by the projectile. So what we are saying is uy is only affecting the height that the object is going to attain above the projection plane, whereas ux, the horizontal component, is only affecting the horizontal distance, which is this range that is going to be moved by the object. So since we are looking for the time taken to get to the maximum height, now it means that ux has nothing to do with what? The maximum height. So it means that the only component that is actually working at that point in time is the what? The vertical component of the initial velocity. So it means that our u is going to become u of y, which is going to become what? U sine theta. So when we substitute to our equation, we're going to have v is 0. So 0 will be equal to u is u sine theta. So we have u sine theta minus gt. So we're looking for t. We cross to the other side. So we have gt to be equal to u sine theta. So t will now give us u sine theta over g. So this gives us an equation for the time taken for an object to what? To get, for a projectile to get to the maximum height, where u is the initial velocity, theta is the angle of inclination, and g is the acceleration due to gravity. Okay, so the next thing we will be looking at is the time of flight. The time of flight. And what is the time of flight? Now, when we talk about the time of flight is a time taken for a projectile to return back to the what? The projection plane again. Is the total time from this point of projection to return back to the what? The projection plane again. That is the what? The time of flight. Okay, so it means that the time of flight can be taken to be what? Twice the time taken to what? To get to the maximum height. It means that time taken for an object to move from this point to the maximum height, and also time taken for it to move from this maximum height to the projection plane. But experiments have shown that time taken for an object to get to the maximum height is the same as time taken for the object to move from that maximum height to the what? The ground or the projection plane. It means if the time taken from here to here is t, time taken from here to here must also be the same t. So it means that our time of flight, capital T, can be taken to be what? 2t. That means twice the what? Time taken to get to the projection plane. Okay, so it means our t becomes, we already know the time taken for it to get to the maximum height. So that will give us 2 times the time taken, which is u sine theta over g. So our time taken, time of flight will give us now u sine theta over g. So this gives us an equation for the time taken for a projectile to, this gives us an equation for the what? The time of flight. We are going to continue with the maximum height. Okay, so what do we mean by this maximum height? Okay, so the maximum height is defined as the what? The highest vertical distance or height as measured by the projectile from the what? The horizontal projection plane. So we are saying that the highest height, vertical height or distance moved by the what? The projectile from the point of projection or from the projection plane. This horizontal line is considered the projection plane. So this highest vertical distance is called the what? The maximum height. Okay, so an equation for the maximum height of a projectile. Okay, so to obtain an equation for the maximum height, let's still make reference to our equations of motion under gravity. Now, why are we always making reference to equations of motion under gravity? Because a projectile is still an object that is what? Under the influence of the what? The gravitational force or field of the earth. So, from our third equation of motion under gravity, we have, well, we know that v square is equal to what? U square plus or minus 2gh. Let me put the h in capital to denote the maximum height. Now remember, still for an upward movement, it's going to be what? Minus 2gh. for a downward movement, is going to become a what? A plus 2g. So since the projectile is still moving upward, that is against gravity, that makes it to become what? Minus 2g h. All right, so we are talking about at the maximum height. So at the maximum height, our final velocity v is still equals what? 0. Because at the maximum height, the velocity, final velocity is equals what? 0. And our initial velocity u is still going to become what? The vertical component of the what? The initial velocity, which is equals what? U sine theta. Remember we said that what? The vertical component is only what, or the vertical component is only affecting the what, the vertical height of the what, the object, whereas horizontal component only affects the what, the horizontal distance moved by the what, the projectile, or the range of the projectile. So u is still the same thing as what, u of y, which is what, u sine theta. Okay, so on substitute our equation, we have v is 0, so 0 square will be equal to u square, which is u sine theta all square, then minus 2gh. So 0 square is still 0. When we open this bracket, that will give us u square sine square theta, then minus 2gh. Okay, so we are looking for h. We'll move it to the other side. So we have 2gh to be equals u square sine square theta over 2, sorry. So that will give us, so we are looking for h. So we divide both sides by 2g. So our h becomes u square sine square theta over 2g. So this gives us an equation for the what? The maximum height of the projectile. However, for this height to be what? To be a maximum, the projectile must be projected at a particular angle. The projectile must be projected at a particular angle. And what angle is that? Now let's obtain the angle. So for this entire quantity to be maximum, the whole of sine square theta must be equal to what? 1, because the whole of this trig function here is tending to reduce the value of what? Of u. So if the whole of this is 1, then it doesn't have any effect on what? On u. So for this to be maximum, sine square theta must be equal to what? 1. And if sine square theta is equal to 1, what is going to be theta? So for us to get theta, we need to what? Take the root of both sides. So when we take the root of both sides, we're going to be having sine theta to be equal to what? Square root of 1. And square root of 1 is still 1. So sine theta is equal to what? 1. So theta becomes what? The sine inverse of 1. And sine inverse of 1 is 90 degrees. Okay, so it means that for the projectile to be projected, or for the height to be maximum, the projectile must be projected at an angle of what? 90 degrees to the what? The projection plane. Okay, so the next thing we'll be looking at is the range of a projectile. Okay, so what is the range of a projectile? Now, the range of a projectile is the horizontal distance or horizontal displacement measured by the projectile from the point of projection to where the projectile hits the projection plane again. So we are talking about the distance or displacement measured by the projectile from this point to this particular point. So that is the range. So it means that the range is a what? It's a distance, or is a what? It's a displacement. And remember that displacement of a body is the product of what? The velocity of the body times what? The time taken. So it means that the range is a displacement. So it means displacement is the same thing as range, and velocity, which is what? The initial velocity of the projection multiplied by the what? The time, which is t. Okay, but then the velocity of the body has two components, which are the what? The horizontal component and the vertical component. So which of the components are we using? We are using the horizontal component because it is only the horizontal component that affects the what? The horizontal distance moved by the what? The projectile. whereas the vertical component only affects the what? The vertical height moved by the what? The projectile. So it means that U here is the same thing as what? UX. And T here is the what? Is the time of flight, not just the time taken to reach the maximum height, because we are talking about the distance moved from this point of projection to this particular point. And the time taken for it to move in this entire curved part is the what? The time of flight, not just the time taken to move to the maximum height. Okay, so we'll substitute our equation for ux and then our time of flight, obtain that of the range. Our range will now be equals, now ux, which we know is what? U cos theta. So we have u cos theta multiplied by the time of flight, which we know is equals what? 2u sine theta over g. So we'll multiply them. Our range now gives us 2u squared sine theta cos theta over g. Okay, so 2u squared sine theta cos theta over g. Okay, so we're going to apply some trigonometry what? Identities. So from a trigonometry identities, that when we have sine of a plus b is the same thing as sine a cos b plus sine b cos a. And if this place is minus, this also becomes minus. Similarly, if you have cos of a plus b is the same thing as cos a cos b minus cos a, minus cos b cos a. Okay, so that is the word that if this place is a minus, then this becomes a plus. So that is the word a trigonometry identity. However, we are only concerned about the what? The first identity. So if we change what? This b to be a, it means that we have sine of what? A plus a to be equals to sine a cos a plus sine a cos a. And sine of a plus a is what? Sine 2a to be equal to sine a cos a plus sine a cos a. That gives us 2 sine a cos a. However, a is just an angle. Remember, a and b are different angles. So if a is an angle, it means it can be substituted with any letter. So we can similarly say it's the same thing as what? Theta. So sine 2 theta is the same thing as 2 sine theta cos theta. So which is identical to what we have here, because here we have 2 sine theta cos theta. So it means we can substitute 2 sine theta cos theta with what? Sine 2 theta in a way of simplifying the what? The equation. So when we substitute that, so we can say that bet sine 2 theta is equals to sine theta cos theta. So substituting that, our range now gives us u squared times sine 2 theta then over g, because the whole of 2 sine theta cos theta has been taken care of. So we're only left with u squared multiplied by the sine 2 theta over g. So our range now gives us u squared sine 2 theta over g. Okay, so this gives us an equation for the what? The range of the projectile. However, for this range of the projectile to be maximum, the whole of sine 2 theta must also be equal to what? To 1. It means that sine 2 theta must be equal to what? 1. So if sine 2 theta is equal to 1, what is going to be the value of what? Theta. So let's obtain that. We are looking for theta. So take sine inverse of both sides. So we have 2 theta to be equals to sine inverse of 1. So 2 theta becomes sine inverse of 1, which is 90. So we're looking for theta, divide both sides by 2. So this goes with this. So theta is equals what? 45 degrees. So it means that for the range to be maximum, then the projectile must be projected at an angle of what? 45 degrees. So all these are what? Very, very important. Remember, for maximum height to be maximum, theta must be equal to what? 90 degrees. But for your range to be maximum, then theta must be equal to what? 45 degrees. So we've come to the end of today's lesson. Thanks for watching. Please Please make sure you like and subscribe to my channel for more videos like this. Bye.